Welcome to SMR Innovations, a leading website development company dedicated to providing exceptional digital solutions for businesses of all sizes. At SMR Innovations, we understand that a website is more than just an online presence. It is a reflection of your brand, values, and offerings. That's why we go above and beyond to ensure that our clients' websites are tailored to their unique needs and goals and are equipped to drive growth and success. Our company's values: first is customer satisfaction. We prioritize the needs and goals of our clients and work tirelessly to ensure their complete satisfaction with our services. Second is innovation. We embrace new technologies and industry trends to provide cutting-edge solutions that help our clients stay ahead of the curve. And lastly, the third one is integrity. We operate with the highest levels of professionalism, ethics, and integrity, and always act in the best interest of our clients. Our company's mission at SMR Innovations, our mission is to empower businesses to succeed in the digital age by providing exceptional website development and digital marketing solutions. We are committed to leveraging the latest technologies and proven methodologies to create custom websites that are visually stunning, user-friendly, and optimized for search engines.
Good morning, this is Mariel speaking. How can I assist you today?
Hi Mariel, I'm calling from a local bake shop. We're interested in creating a website for our business.
Wonderful, we'd be delighted to help. Could you tell me a bit more about your bake shop and what you envision for the website?
Sure, we specialize in artisanal pastries and cakes, and we want the website to showcase our products, allow customers to place orders online, and maybe even schedule custom cake consultation.
That sounds fantastic. At SMR Innovation, we specialize in crafting user-friendly and visually appealing website. So, have you thought about any specific designs, elements, or feature would you like to incorporate?
We're open to suggestions, but we definitely want it to reflect the cozy and inviting atmosphere of our bake shop. And it should be easy for customers to navigate and place orders.
Understood. We'll prioritize a clean and initiative design with clear navigation, menus, and a user-friendly ordering system. How soon are you looking to have the website up and running?
Ideally, within the next month, we're excited to expand our online presence and reach more customers.
Not a problem, so we'll work efficiently to meet your timeline and ensure everything is tailored to your satisfaction. So I have one of our web developers reach out to you shortly to discuss the specific in more details.
Great! Thank you so much, Mariel. We're looking forward to working with the SMR Innovation. Okay?
It is our joy, so we make sure your Big Shop online presence is a delightful as your pastries have a wonderful day. Thank you.
You too, Mariel. Goodbye.
We now have the convention node and project activity schedule. To visualize the whole network diagram in the following procedure, let's first create a basic illustrating of the project network. A has no predecessor, so it will begin at start. Activity B needs A to be completed before it can start. Activity C depends on A to be completed before it can start. Activity D depends on B to be completed before it can start. Activity A depends on B to be completed before it can start. Activity F depends on C to be completed before it can start. Activity G depends on both B and E completed. Activity H depends on both E and F completed. Activity I needs both G and H to be completed. Since I have no successors, it goes to finish. Here's the network with activity nodes showing the letters and time. Now that we have all of this information, we were able to create a critical path method. But first, let's create the project's activity schedule. The steps listed below should be followed while implementing critical path method networking. Build the project network. Conduct both forward and backward passes. Determine when the project will be finished. Compute the slack values. And last, demonstrate the critical path. We will now use this nodes convention where A is what activity is being described and T is for estimated activity time duration. ES stands for earliest time can start, while EF stands for earliest finish time. LF stands for latest starts time, while LF stands for latest finish time without exceeding the project's time complexity.
Let's start doing the forward pass. A has no predecessor, so its earliest start time will be 0. Since it has 5 days to be completed, its earliest finish time will be 0 plus 5, which gives 5 days. Now, B needs A to be completed before it can start. Since the earliest finish time for A is 5, then the earliest time in B can start in 5. And with an activity time of 10 days, B will have an earliest finish time of 10 plus 5, total of 15 days. C needs A to be completed before it can start. Since the earliest finish time for A is 5, the earliest time in C starts in 5 with an activity time of 13 days. So C will have an earliest finish time of 13 plus 5 is equals to 18. Next, D needs B to be completed before it can start. Since the earliest finish time for B is 15, and the earliest time in D can also be 15 with an activity time of 7 days. D will have an earliest finish time of 7 plus 15, total of 22. E needs B to be completed before it can start. Since the earliest finish time for B is 15, then the earliest time in E can start in 15. And with an activity time of 3 days, E will have an earliest finish time of 3 plus 15, which has a total of 18 days. F needs C to be completed before it can start. Since the earliest finish time for C is 18, and the earliest time in F can start in 18, with an activity time of 9 days, F will have an earliest finish time of 9 plus 18, which gives 27 days. As you can see here, G have two predecessors, E and D. Since D have the highest and the earliest finish time to be completed, G can start in 22 and with an activity time of 4 days. So, G will have an earliest finish time of 4 plus 22, total of 26. H here needs E and F to be completed before it can start. Since F is the highest and the earliest finish time of 27, then the earliest time in H can start in 27. And with an activity time of 3 days, H will have an earliest finish time of 3 plus 27 is equal to 30 days. Lastly, I needs H and G to be completed before it can start. Since the earliest finish time is 30 and the earliest time in I can start in 30 and with an activity time of 7 days, H will have an earliest finish time of 7 plus 30 has a total of 37 days.
Now, let's do the backward pass. Since the project completion time is 37 days, the latest finish time for the activity of the finished node of I is completed in the shorter time in 37 days. To compute the backward pass, we will determine the latest start time by subtracting time in the latest finish time. For I, the latest start time will be 37 minus 7 to give 30. Now, H has only one successor, which is I, that has the latest time of 30 minus 3 to give 27. G has only one successor, which is I, that has the latest start time of 30 minus 4 that gives 26. F has only one successor, which is H, that has the latest start time of 27 minus 9 that gives 18. Now, E has two successors, G and H. Their latest start time are 26 and 27. So, the latest start time of E will be the 26 minus 3, which give 23. D has only one successor, which is G, that has latest start time of 26 minus 7, which give 19. C has only one successor, which is F, that has latest start time of 18 minus 13, which give 5. B has two successors, D and E. Their latest start time are 19 and 23. So, the latest start time of B will be the 19 minus 10, it gives 9. And also, the activity A here has two successors, B and C. Their latest start time are 9 and 5. So, the latest start time of activity A will be the 5 minus 5 that gives 0. Now, we are done in backward pass.
Will we now get the slack equals LS minus ES or LF minus EF. Activity A, 0 minus 0 equals to 0, or 5 minus 5 equals to 0. The slack of activity A is 0. Slack for activity B is equals to 4. Slack for activity C is equals to 0. Slack for activity D is equals to 4. Slacks for activity E equals to 8. Slacks for activity F is equals to 0. Slacks for activity G equals to 4. Slacks for activity H equals to 0. Slacks for activity I is equals to 0.
Activity A, C, F, H, and I is an activity cannot be delayed at all without extending the project completion time. The activities with zero slack are called critical activity, and they form the critical path, which is longest path in the network. So, the critical path here is A, C, F, H, and I. and that how to construct the critical path diagram.
By embracing the critical path method, we've not only optimized our production processes, but also enhanced our overall competitiveness in the market. Thank you for choosing SMR Innovation. Thank you for joining us on this journey in finding the critical path. Together, we're shaping the future of creating businesses' websites.